Good day. In this video, we will discuss the patterns of surface water circulation. We will be having a discussion on the ocean currents, gyre, the global conveyor belt, and the upwelling and the downwelling. Let's begin this lecture with some historical trivia. The person in the picture is Harari's Bergeron. His theoretical understanding on the effects of boundary or a continent on ocean circulation allowed for calculation of surface flows via wind stress. And in his honor, the water transport unit was named after him. This is his bird drop, which is equal to 1 by 10 raised to 6 cubic meter per second. Currents. What are they? And what do they arise from? Currents are located all around the globe. Some are located along the eastern and western sides of the ocean basins. Some are located at the equatorial region, and there are those at the south polar region which travels globally from east to west. Currents arise from an intensification of gyre circulation, and this is in response to variations in the Coriolis effect with respect to latitude. To name these currents, we have the western boundary currents, the eastern boundary currents, the equatorial current, and the Antarctic circumpolar currents. Let's discuss the western boundary currents. These currents are located along the western sides of the ocean basins, and take note that all of the currents here are fast moving and narrower as compared to the other currents. Let's take some examples of these western boundary currents. Take a look at the North Atlantic Ocean. We could see there the Gulf Stream, and this is the most famous current of all. This has a speed of approximately 2.3 meter per second, and it transports warm water from the Gulf of Mexico to North Atlantic Ocean. Another example is at the North Pacific Ocean. Take a look at the North Pacific Ocean. We could see there the Kuroshio current, and this Kuroshio current has a speed of approximately 2 to 2.5 meter per second, and its flow is somewhat complicated. It travels at the Japan archipelago. Next example is the South Pacific Ocean current, the Brazil current. Take a look at the South Atlantic Ocean. This Brazil current forms highly productive large marine ecosystem, and we have there the what we call Patagonian shelf, which I will be discussing in the next series of the video. Take note that this increase in flow rates of western boundary currents are caused by the Coriolis effect, which increases at higher latitude. I repeat, Coriolis effect, which increases at higher latitude. Let's discuss the eastern boundary currents, which are located along the eastern sides of the ocean basin. Example is the California current, which is a slow moving, having an approximate speed of 1 foot per second. Take note, 1 foot per second. And this brings cool water, which creates coastal upwelling and a moderate climate. California current, a slow moving current, has another name, which is the Mediterranean current. And this Mediterranean current produces considerable fog. Next is equatorial current. These are weak and seasonal, and they return some of the warm waters which flows eastward. These equatorial currents may play a role in the formation of hurricanes. So if you could see the image at the left, that is a satellite image of a hurricane alley formed at the equatorial region of the globe. The Antarctic Circumpolar Current, or the ACC. This current is the only continuous current unimpeded by land masses. If you are to take a look at its geographical form, that is the lone proof of its unimpededness. This ACC is the important exchange point for waters of all the three oceans, namely the Atlantic, the Pacific, and the Indian Ocean. Now let's talk of the gyres. Gyre arises from encircling currents, and we have 5 major ones generally called as subtropical gyres. We have first the North Pacific gyre, the South Pacific gyre, the North Atlantic Gyre, the South Atlantic Gyre, and the Indian Gyre. We also have subpolar gyres located along the north and south poles of the globe. Take note that each of these five subtropical gyres arises from at least four currents, and subpolar gyres, on the other hand, arises from at least two currents. We will discuss further in the next chapter of this video series. Currents form gyres, and these gyres circulates warm and cold ocean waters around the globe. This image summarizes the warm and cold currents we have on Earth. Now, the red arrows represent the warm waters being flowed, while blue ones represent cold waters. Therefore, red is warm current and blue is cold current. On the other hand, the black arrows represent the well-mixed ocean water currents. Currents form gyres, and these gyres circulates warm and cold ocean waters around the globe. This image summarizes the warm and cold currents we have on Earth. Now, the red arrows represent the warm waters being flowed, while blue ones represent cold waters. Therefore, red is warm current and blue is cold current. On the other hand, the black arrows represent the well-mixed ocean water currents. All this deep water movement creates the global conveyor belt, or the what we call thermohaline circulation. So what is this thermohaline circulation? Thermo means temperature and halines is salinity. So therefore, this thermohaline circulation, or the global conveyor belt, is temperature and salinity dependent circulation. This image shows the model of this thermohaline circulation, or the global conveyor belt of Wally Broker. This shows deep water formations plus returns. Now, in this image, we can see that there are two major sites for deep water formation. Take a look at the NADW on this image and the AABW. Now, NADW is the North Atlantic deep water, while the AABW is the Antarctic bottom water. So that ends my presentation on patterns of surface water circulation. We talked of the ocean currents, the gyres, the global conveyor belt, and the phenomenon of the upwelling and downwelling processes. See you again for the next video series.